Students, we will continue our last video on how ionic compounds formed. Hello students, welcome to the class back, and I just want to explain you the last video about valency. I would like to continue that because I think basics are clear, then future studies are going to be the best. So let's start. This we have already done in 9th class, so please understand carefully. For bonding, these things are very much required.
Hydrogen is capable of reacting with several other elements, while helium never really does. Helium is a quiet, unreactive element that does not participate in reactions. But have you ever wondered why? What makes helium and many other elements also like neon, argon not participate in chemical reactions? And another question we would have is what makes other elements react spontaneously with each other? The answer is valency. Yes, one of the most important factors for reaction is the concept of valency. But before that, let's have a look at an important concept called the electronic configuration. Now, what could this be? As the name suggests, electronic refers to electrons, and the term configuration literally means arrangement or layout. That means the electronic configuration of an atom is the arrangement of its electrons in the shells. As simple as that. There are two facts that we need to recall. First, the innermost shell, or the first shell rather, has a maximum of 2 electrons that can be accommodated in it. Secondly, from the second shell onwards, whichever is the outermost shell, it can accommodate a maximum of 8 electrons. In simpler words, outermost orbital can contain 8 electrons at max. This state is called as the octet state. The term originates from the Greek word octa, which means 8. The octet state is considered to be a stable state. Let's understand this in a simple way. You love chocolates. Now, if there is a bag of chocolates kept open before you, how many will you try to grab at once? Needless to say, you will try and take as many chocolates as your hand can accommodate. That means the maximum number of chocolates is what anybody will wish for. Now, what have chocolates got to do with electronic configuration and valency? Let's understand the relation. As a part of human tendency, we will try and grab the maximum number of chocolates using our hands. Similarly, the atoms would want to have maximum number of electrons their shells can accommodate. That means if it's just one shell like in the case of hydrogen or helium, then the atoms would want to have 2 electrons in it. That will be the outermost shell of the atom. This will help them achieve a stable state. Similarly, for all the other atoms having more than one shell, it's obvious that they will wish to have 8 electrons in their outermost shell. And why is this so? That's correct. It's because the outermost orbital of any atom can accommodate a maximum of 8 electrons in it. That is the reason why all the atoms of various elements are in a constant struggle of attaining 8 electrons in their last shell. That is, achieving the octet state. However, it's not possible for all to have 8 electrons in the outermost shell. Imagine the case of oxygen. It has a total of 8 electrons. So can we just have one orbital around the nucleus containing all the 8 electrons? Absolutely not. In fact, according to the rule, we have to fill 2 electrons in the first and the remaining 6 electrons in the second shell. Because the capacity of the first shell is to accommodate a maximum of 2 electrons. So can we say that the electronic configuration of oxygen is 2,6? That's right. But now this indicates that oxygen does not have 8 electrons in the outermost shell. So how will it achieve its stable state? What can be done to have 8 electrons in the outermost orbital? Yes, oxygen can borrow or share electrons with atoms of other elements, right? Absolutely. This is how chemical reactions happen. Wait a second. Are we saying that chemical reactions occur because atoms of various elements give or take or share electrons between them? That's correct. And is this how compounds are formed? Absolutely.
This is the story of formation of compound. I hope your basics are clear and you understood. Thank you. Bye-bye.